I'm Fabian. As I said, I am the co-founder of KYVE Network. As I said, I'm huge FOMO basically not being in Austin. We just launched our mainnet a couple of weeks ago, so I have to kind of like stick here on the ground in Germany, make sure everything goes smooth. If you have any questions about KYVE, about the power of anything, Paul from our team is on the ground. Maybe he can, I don't know, raise his hand right now or something. He wears the same kind of t-shirt than I do with a little KYVE written on it, so you should be able, I think, to find him. And yeah, let's get started. So this talk is about KYVE, a decentralized data lake, and kind of about how we build it, and also how we leverage IBC, basically how we allow also like data transfer across Web3. Maybe a couple of words about myself in the beginning. I'm Fabian, I'm a software developer here in Germany. I came to the crypto space it was probably mid 2019 with a hackathon that happened here in Germany. I actually came in from the data side, and so it was a hackathon, and I was looking into actually storing signature data, like real world, like DocuSign signature data onto the blockchain. Kind of started there, and then got introduced to the IBC ecosystem, and was super fascinated by that, and then started out there. I met my co-founder John, also there. We were together working on a project called Verify, where we were measuring like network traffic, and then we're able to convert this into like a trust score, how trustworthy is an address, kind of like an on-chain KYC, thing without having any private data. And then suddenly one day, John and I were browsing through Gitcoin, and we saw a grant from Parity and Arweave to bridge Parity's data onto Arweave. And this is how the whole idea of KYVE and everything got started. We're gonna just go over a couple of things today, kind of like what are the problems in the data space and why KYVE, data pipeline. Our new Oracle module is going to be rolled out very soon, which leverages IBC, kind of like how we connect that, a little bit about the roadmap and our tech journey, because we have seen many things kind of like over time. So first of all, what are the problems we are facing in the data world? A lot. So basically, the problem is the blockchain itself, right? We are trying to condense so many information into transactions and into blocks that it's super cool and it's fully decentralized. But the problem is actually how do we get all these single data items out of there again? And I think every one of you who work with Solidity smart contracts really knows the problem. You're meeting events, but then you have to connect your node, and then you have to decode the events and then load them into your database. And it's also a lot of repetitive, right? If you think about it, like every smart contract faces a problem, every blockchain kind of faces the problem. You know, on the Cosmos SDK-based chain, it's also there. The events are quite hard to access, but this is actually where kind of like the true value lies. And so whenever you're a data engineer, data analyst, and you want to basically go ahead and do like data analytics on your data, create some metrics, or maybe even archive a node, you have to spin up the whole stack yourself. You have to run your own node. It can be insanely costly, although the data you're accessing is actually the same. I mean, Bitcoin block 0 looks the same all around the world since almost 14 years now. And so kind of like, well, why is there not like one single place where everything is stored? Well, the problem is that then it's centralized, right? If we take Bitcoin block 0 and KYVE puts it on S3, then why should a different developer trust that, right? I mean, there might be certain attack vectors that you can introduce. For example, talk about node syncing. You can provide invalid snapshots and make the other validators that are syncing your node run into problems. So how do we kind of like create like a trustless data environment, right? Without basically having the risk of running into invalid data, and also especially kind of like out-of-date data, right? We have this a lot, actually something we see with KYVE quite often, where some nodes are synced and some nodes aren't fully synced yet while the block is being committed. Actually happens more often than you think, so you would get different results if you only trust one endpoint. So it's actually quite a difficult problem to tackle. And then, let's say all of this is successful, then you still have different data requirements depending on your use case, right? Do you want to maybe dive deep on a single address for accounting purposes, for example? Well, then you would probably want to go with a database that allows you to do kind of like in-depth queries with a very well transformed data set. You can do all these deep queries. But if you want to maybe get a holistic view about an ecosystem or compare one ecosystem to the other, you might want to also opt for a different data warehouse, right? Data storage solution. So we kind of like need to find a way to bring all of this together. And this is why we created KYVE. So KYVE is a fully decentralized data lake, and it's also fully permissionless. So kind of like how does this work? How did we get started with this? So basically, in the beginning, it was, as I said, like the grant from Parity. So we looked at the data that Polkadot was uploading and thinking about, okay, if we are now like the single entity and we relay the data, we fetch it from the IBC endpoints, that's pretty straightforward. And then, well, we can add other chains now, right? We can consume Polkadot, we can consume Moonbeam, we can consume Athmos, and all the other fun data products. And we call them a data pool. So basically the way this works is KYVE fetches data from a blockchain, from an RPC endpoint, from an API endpoint, and then stores this on permanent storage like Arweave. We're utilizing Bundler Network for that. There are also other storage options out there. And then basically we also build a data retrieval framework on top of this. And so the whole concept of this is that we have these data pools where a developer basically can run customized code where they just have to specify a function on like how is data getting uploaded and how is data getting validated. So in an easy blockchain archiving process, you would say, well, I would connect to an RPC endpoint, let's say Polkadot, query Polkadot block 5, take that down, store it onto Arweave, and then have other nodes download the data and then run a validation check against that. And if the nodes were valid, perfect. If the nodes were invalid, that's not good, right? So we keep track on the chain about valid and invalid data. So basically, in the end, the KYVE chain creates all valid data points, or pointing to all the valid data points that we have uploaded to permanent storage. So then developers, while doing the data retrieval, can just simply query through all the valid bundles, download the data that we have stored, and then load it into their database. We have a lot of active integrations on our testnet right now. We really kind of like cover every ecosystem there. As I said, we started out heavily on the layer 1 side. We had Avalanche as one of our first partners, Polkadot, Interchain Foundation as well, kind of like to always offer this archival process. Because the blockchains noticed, actually, although they're all different ecosystems, they're all facing the same problem. And the problem really being like, well, over time, it is tricky to sync all the data in a trustless way. Because if you think about it already, if you want to join Ethereum, for example, and you would actually start syncing from block 0, this takes a while, just pure data processing and validating that. And also, there is no incentive actually for archival nodes, right? Because if they are not used for producing new blocks, then the question as a validator is, why would I keep this heavy data infrastructure running? And why do I basically have to provide this if I don't build an external incentive mechanism on top of this? And then even the other question is, well, if I'm a validator and I already have a good position in the network, why would I want other validators to join? Well, you could say they do it for the sake of decentralization, which is, of course, perfect. But basically, it's not a 100% secure solution, it's not a 100% guaranteed solution that you will always be able to really sync all the data from day 0. And so we got together with all of these blockchains, and for them, we developed the archiving use case, where basically KYVE is storing the original block data one by one onto Arweave, is validating it, and then kind of like keeping track of this on the KYVE chain. And for Cosmos chains, we have a tool called the block sync, where we actually are mocking the block sync functionality from Cosmos chains, and then allowing you to spin up a new validator without having to connect to the rest of the network. So basically, this block sync software mocks being a peer in the network, but it's actually connected to KYVE data. So you can request it insanely fast and pull down all the data that KYVE has archived without you having to worry about the actual building the data infrastructure, building the data pipelines behind this, getting it into Node and transforming it, because we're already utilizing data that is out there. The other very cool benefit of this, this architecture with these data pools is that, of course, now other developers can also start utilizing the data that we have archived. So just because there's now Bitcoin blockchain data there that you can use to sync your Bitcoin node, you can of course also create a local copy into your own data warehouse and then run like data-driven insights around this, analytics about it. You can compare different ecosystems, and the data is there, and because it's stored on Arm, it's actually also free to access it. So how do we enable it that it's free to access? The way it works is a funding mechanism. And so these data pools require KYVE tokens to upload the data. So every time a piece of data gets uploaded and validated, the protocol node that has uploaded the data receives KYVE token as a reward. If a pool ever runs out of data, it simply pauses, meaning that no new data is being produced. So if you think about it, let's say we have 20 data pools and we might archive a weird data source that no one is really interested in, that this data source would not attract any funding, and basically then also would not create any overhead in the network. And then what happens over time is businesses start building use cases on top of this publicly accessible data and are starting to kind of monetize the data they are using. Think about you're building an indexer, for example, and you are selling off the indexing endpoint to your customers. Well, then you have a huge incentive, right, to keep the underlying KYVE data running and making sure it's funded, to ensure this stream of data is still ongoing. But of course, because we utilize permanent storage, the moment someone has paid for a piece of data, it's there forever. So this is like a super cool, I think, dynamic you don't see around other networks, but really utilizing free data access for already stored data, and then kind of like this funding on the go model when you want to store data. And another cool concept is, of course, you can even share the funding. So I don't know, for example, for Solana or for Cosmos, there might be multiple people being interested in actually accessing and monetizing the data. So instead of one party having to fund all of it, they can actually all chip in on the funding, share the costs, basically increase their profit, and then making sure that no one drops out, but the data is still produced. So if you're now a developer and you want to work with the data, you should follow the ELT principle. So ELT means you extract the data, you load it into your destination, and then you transform it. There's ELT versus ETL. And ELT in the blockchain world makes more sense because we work with a lot of raw data. As already said, data is usually highly compact, and it's usually kind of like really packed into the format, and then by transforming it in your data warehouse, you can really customize it to your needs. So let's say I want to create like holistic views versus someone who wants to get certain insights on a different transaction or on a different address. That single person might, for example, only run a filter on, hey, now I have all the data loaded in my database, now just give me all the transactions of this address, and you can create a custom transformation towards that. But if I want to, for example, create a holistic view about everything that's going on, I might want to sort my tables differently or arrange them differently. And by using this ELT approach, we ensure that the raw data KYVE is stored, provides the most value for all the data scientists out there. And because, while we don't want developers to go through the need of creating their own ELT pipeline, we released KYVE Data Pipeline, which is a no-code solution to all of this. We are utilizing a open source framework called Airbyte, where we have a KYVE source, and then Airbyte supports tons of destinations. I mean, you see Snowflake, BigQuery, S3, kind of like everything that the data engineer parts really want. And you can just connect them to all the KYVE pools. And if you want to check it out, you can go to docs.kyve.network into the Accessing Data ELT Pipeline section. We have a couple of tutorials there and kind of like cover all the huge use cases, starting from how do I get my data to Snowflake, how do I get my data to Postgres, and kind of like how do I get started. And I mean, once the data is in the data warehouses, the possibilities are really endlessly. So why not directly basically loading the data from the blockchain into the data warehouse? Well, first of all, you have to trust an endpoint. So you would either need to purchase your own endpoint, which is expensive. You have to run it continuously, even if you might not use the application right now. So you kind of have like a lot of high base cost. You might actually have data in your data warehouse that you're not even using because you have to connect through the raw blockchain. You have to write transformations yourself. It gets even worse if you want to do specific analytics, for example, on smart contracts, where then you have to go decode the smart contracts and the events yourself. And this is kind of like exactly where this no-code solution comes in. Connected to KYVE Pool, you exactly know the data this KYVE Pool is storing, and just load it into your warehouse, get started. If you have multiple use cases, get it into multiple warehouses at the same time. I think every developer really has their own flexibility there and really knows what fits their use case best. And I think now the most interesting part that KYVE allows is how actually we utilize IBC. So maybe to walk you guys a little bit how our development roadmap looked like. We started out being fully Arweave based, storing the data on Arweave and utilizing Arweave smart contracts. This was almost 2 years ago. And then we noticed, well, actually, our Arweave smart contracts are not as production ready back then than they would need to be, bring this to the next step. So we kept storing the data on Arweave, but then swapped our token logic out to a Solidity contract. And then there ran pretty fast into the problem of the block space, which was during the bull market where Ethereum was just crazily congested, all EVM chains were basically congested, and KYVE is really like a high volume, less value based application. So what this means is, let's say you do a trade on Uniswap, and I don't know, you make $10,000 profit on it, you will always pay $100 in gas, right? Because when you make the profit, that's not a problem. But with KYVE, because we upload so much data and we have to submit it to the chain, we really have to create a lot of transactions, and not every transaction might be worth the gas that has to be paid to execute it on an EVM-based chain. So this is why in February last year, we decided to switch to a Cosmos SDK chain because it gave us so much more possibilities. It gave us way more freedom in integrating KYVE, fulfilling the vision there, adding more features that were pretty hard to implement in Solidity, and also especially using IBC. And so what is super cool is this X/Oracle module that we will probably be releasing in a couple of months. It's utilizing the newly released IBC middleware, and it's wrapping the ISS 20 standard, allowing full backwards compatibility. So what does this mean? Basically, this means that we're already integrated with all IBC-enabled chains with 0 code changes. So if you want to query for data that has been stored with KYVE from your chain, you can just route it through IBC, select the query that you want in your message, and by this, of course, enable trustless access to the data. So I don't know, let's say you're building, you're building an application on a chain, you're building your own app chain that has high data needs. Store the data with KYVE and then access it from the chain via IBC. And the cool thing is, thanks to Accelerate Squid, actually it allows the user to pay any token they want as long as the token, of course, is traded on Osmosis. And so this is, of course, super, super beneficial, especially going back to the funding mechanism that we have created, where now the moment you query for data, actually, to get it from your chain to from KYVE chain to the other chain, you just pay in your native token, so you don't have to worry about it, and you just route it into KYVE tokens, and so every chain has their own mechanism, and you really ensure that the data that you're using with your chain keeps on being produced. Maybe also quickly going about the roadmap that we have been through. As already said, we've been through quite some exciting code changes there. We launched our incentivized testnet last year. We had a lot of success and already had a lot of people battle testing on KYVE. We launched our mainnet March 14th, which was a crazy time. It was very, very exciting. We will soon launch the protocol, so all the data layer on mainnet. This will also happen in a couple of weeks. We already have released the data layer on our testnet Kaon. That actually happened 2 days ago. So if you want to give that a try and see what it looks like, head over to app.kyve network, and you can switch to Corellia, which is our incentivized testnet, and you can see all the crazy data pools being deployed there, or to Kaon, which is more of like a mainnet replica, and there you will see our first data pool, which is the Cosmos Hub data pool, and then, as I already said, again, with the syncing use cases really allowing you to bootstrap your node there, doing all these exciting experiments inside the Cosmos ecosystem. The other next two big things are, of course, our token listing and the Oracle launch. And then I think for the rest of this year, it's going to be data pools, and data pools. We have like really trying to create a huge stand in the Cosmos ecosystem, especially starting with the chains there, and from there on extending to pricing information, so you can work with the Oracle, other types of data like weather data, sports data, and then of course also EVM data, smart contract data, and kind of like starting to build this huge data set. If you have any questions about KYVE, what we do, how we utilize IBC, feel free to reach out to Paul on the ground. I hope he's around. And feel free to ask any questions. Feel also free to join our socials, Twitter, Discord, Telegram. Feel free to ask any questions there. We're always happy to help you. And yeah, thank you so much for this. And I'll now jump back.